Hello, in this video, I will be talking about confidence intervals for variance and standard deviation. In order to be able to construct confidence intervals for variance and standard deviation, we first need to talk about a new distribution. And this is called the chi-square distribution. If you recall, we talked about many distributions up to this point. The standard normal distribution, which was called the z distribution, any x distribution, normal distributions, uniform distributions, binomial distributions, and the t distribution. And there are many more distributions we did not talk about, but keep in mind, now we are introducing a new distribution. This is called the chi-square distribution, and it is based on the same idea that the t distribution was based on. The t distribution was a family of curves based on degrees of freedom. So let's see how they arrive to a new distribution and how important it is to find the values in order to construct confidence intervals for variance and standard deviation. Consider the following statistical experiment. Select samples of size n from a normal population which has a standard deviation of sigma. We find that the standard deviation in our sample is equal to S. Given this information, we can define a statistic, which is called the chi-square, using this formula. So this is the formula defining the statistic, which is called chi-squared. So the symbol right here, it's a new symbol, it's like an elongated X, chi, and it is squared. You see this value right here? It is squared for a reason, because if we look at the following characteristics, we realize that all chi-square values are greater than or equal to 0. This is something new. None of these distributions that we talked about had these characteristics. These distributions were symmetric distributions, but this one is not symmetric. All values are greater than or equal to 0. I said this before. The chi-square distribution is a family of curves, which is based on the idea of degrees of freedom. Look at the graph to the right. We have a degrees of freedom of 15 right here, corresponding to the red curve. Degrees of freedom 10, corresponding to the green curve. Degrees of freedom 5, corresponding to the blue curve. You see, the less degrees of freedom, the more skewed the distribution is. Degrees of freedom formula is n minus 1. The curve is non-symmetrical and skewed to the right. We can see this. The total area is 100%. And the notation used for this distribution is chi-squared, and then as a subscript, we should put the degrees of freedom. The first thing that we will do, we will identify critical values. To identify critical values for the chi-square distribution, we need to look at the table. The table is in the formula cards. It can be found under course documents in our Canvas course. It can be found in the textbook, or you simply Google the chi-square distribution table and you will find a table like this on the internet. Let's take a look at this and practice with finding critical values. Here is the chi-square distribution table. Keep in mind, this table is the only tool we have to find chi-square critical values. These values are not on the TI 83 or 84, so you need to know how to use the table. So I will simply practice on 2 problems. You want to make sure you learn how to do this. So here is the first one that we want to do. Let's just say we have a sample size of 15 and a confidence level of 95%, 0.95. And we are looking for critical values. These critical values will be denoted chi-squared to the right. This is the notation, and chi-squared to the left. Okay, so let's see how do we do this problem. The first thing is make sure you know what the table shows us. We have to sketch the graph corresponding to our situation, but you do realize that this table shows us critical values corresponding to a shaded area in the right tail. So this is the area. So sketching the graph for a chi-square distribution, so this will be a chi-square distribution corresponding to a degrees of freedom of 15 minus 1, because that's the formula, n minus 1, and that will be 14. This is important, okay? And a confidence level of 0.95. So let's see what we do with the confidence level. As we know from the other distributions, the confidence level will be right here in the middle. Now, this is not a symmetric distribution. This is a right skew distribution. Anyway, the area left in the tails should be 1 minus 0.95, which is 0.05 divided by 2. So that area is 0.025. We are interested on the area to the right, you see, because this is the area right here in the table. So as long as I have the degrees of freedom right here, 14, I look at the table for 14. Here is 14 degrees of freedom. So this is the row I'll be looking at. And the 0.025 as a subscript right here. So I'm expecting all of these chi-squared. 0.025, it's right here. So the intersection of these two will give me the first critical value, which is chi-squared to the right. So this will be the chi-squared to the right. And I'll write it down right here, 26.119. It's visible. I'll be using a different color for the other chi-square distribution. So here we have the chi-square to the left. Again, I'm looking at the area to the right of this value. And there are two different ways of finding this area. It will be the white one, which is 0.95, and 0.025, which is actually 0.975. Or you simply subtract 0.025, because right here you have a 0.025 also. You subtract this left area from 1, and you will arrive at this area. So these two areas, 0.975 and 0.025, should add up to 1, and they do. So I'm looking now on the header right here for the chi-square, 0.975, which is this one. I am on the same degrees of freedom. So the corresponding value right here will be chi-squared to the left is 5.629. I'll write it right here, chi-squared to the left, 5.629, and chi-squared to the right is 26.119. So these are the two answers. This is how you should use the table to figure out the critical value. This is the most important part in creating a confidence interval for the standard deviation or for the variance. So make sure you know how to use the table. Let's practice on one more. This time I will ask you to try to do it on your own and then check with what I am doing here. So you can stop the video, do it, and then check. So let's do the problem right here. Let's just say I have a given information like a sample, which is 28. The confidence level will be 0.98. The question is find chi-squared to the right and then chi-squared to the left. Try to do it on your own and then start again the video and see if you got the same values as I do. Here we go. Sketch the graph. This is the chi-square distribution. Degrees of freedom this time will be 27. And I hope you know that is 28 minus 1. This is important because this will guide me to the degrees of freedom of 27, which is down here, still visible on the screen. And now I know that in the middle, I have the confidence level, which is 0.98. 1 minus 0.98 is 0.02. We split that in two because we have two tails right here. So that will be 0.01. I'll add one more zero just because right here I have 3 decimals. So I'll be looking for chi-squared to the right among the values listed at the intersection of chi-squared 0.10. And we have to be careful which one to pick. This is the one. And the degrees of freedom 27. So this will be the value, which is 46.963. So chi-squared to the right is 46.963. I'll be looking now for chi-squared to the left. In order to find that, I need to make sure I know what the area to the right of this value is. But one way would be to add this area to this area, and that is 0.99. Another one will be to make sure that these two add up to 1, or 1 minus 0.01, which is in this left area, will give me the same answer. So it's 0.990. 0.990 will be this one. So that means I'll have to look at the intersection of this column and this row, and I got to this value, chi-squared to the left is 12.879. Okay, so make sure you practice. This is very important, as I was saying, in order to create a confidence interval. So let's see, how do we create confidence interval for the variance and standard deviation? Here are the formulas. Unlike anything that we've seen before, the lower and the upper bounds for these confidence intervals cannot be found using the calculator. They depend on critical values from the chi-square table. So for these ones, we have to use the table and we have to use formulas and plug in values. Here is the first formula for creating a confidence interval for the variance. Here is the variance. Make sure you pay attention to notation. The left bound will be n minus 1 times s squared divided by the chi-square to the right, which you find from the table. The upper bound is n minus 1 times s squared divided by chi-square to the left, that we find from the table. Plug these values, and then, of course, use the calculator to find the actual lower and upper bound. If we are looking for the confidence interval for the standard deviation sigma, all we have to do is drop this symbol, which is square, and apply the square root to the lower and upper bound. The degrees of freedom are n minus 1. Problem 1. The manager of French's is concerned that patrons are not consistently receiving the same amount of French fries with each order. The chef claims that the standard deviation for a 10-ounce order of fries is at most 1.5 ounces. But the manager thinks that it may be higher. He randomly weights 19 orders of fries, which yields a sample mean of 11 ounces and a sample standard deviation of 2 ounces. Calculate a 90% confidence interval for the population standard deviation sigma. So let's write down the given information. And there is a lot of information, actually, some information we do not need. But this problem makes you aware of how we can use statistics in real life situations, like this one. First of all, the manager is concerned about the consistency. When we think of consistency, we think of variation, standard deviation, or variance. And that's the reason the question asks for the confidence interval for sigma. Now, the chef claims something about the fries, and the manager thinks this is it might be higher, actually, and that's why he performs the following experiment. He will actually take 19 order of fries, so 19 will be the sample size, which is n, and that will have a sample mean. So make sure we use the appropriate notation, x bar, which is 11 ounces, and a sample standard deviation, which is S, which is 2 ounces. Pay attention to this. This is not using digits. Okay, now the question is calculate the 90% confidence interval. So right here among the given information, I will add the 90% confidence level, and then the question, calculate or find the confidence interval for sigma. We will start with the formula. So sigma is between these two values, square root of. On the top, you have n minus 1 times s squared. On the bottom, chi squared to the right. And the upper bound, top, stays the same. And on the bottom, we have chi squared to the left. So now we inspect. Do we know n? Yes, n is given. It is right here. Do we know s? Yes. See, we do not need x bar for this problem. That is given anyway. And what else? Well, we need to find the chi-square right and left. How do we find chi-square right and left? Well, knowing the confidence level. So now it is the time that you will practice and you will find from the table chi-squared right and left. So make sure you look at the table. We did practice at the beginning of the video. You can stop the video. And now I will tell you, come back and check. Chi-squared to the right is 28,869. And chi-squared to the left is 9.390. Now that we have all the values, all we need to do is plug in. So sigma is between. On the top, I have 19 minus 1 times 2 squared divided by 28.869. Take the square root of this value. On the upper bound, I have 19 minus 1 times 2 squared divided by 9.390 square root of this value. So now make sure you take the calculator, you plug in the values. Again, you can stop the video and check if you get the same numbers that I have here. For the lower bound, I have 1.579. And for the upper bound, I have 2.769. And this is the confidence interval for the standard deviation of the population. Now, if you think back at the problem, the fact that the manager thinks that this might be higher than 1.5, it is actually proven by these results. It seems that the standard deviation is higher than 1.5. It is actually between 1.579 and 2.79. Here is a second problem. The weight in pounds of 15 dogs selected randomly from those adopted out by an animal shelter last week are shown in the list below. Here is raw data. Calculate the 98% confidence interval for the population variance sigma squared. So I will write down what's given. And we have a lot. When we have raw data, we have a lot if we know how to use it, of course. We know the random variable is actually weights in pounds. We know n is actually 15. If it's not given, we simply count the values and we figure out those will be 15. And we know that we have to calculate the confidence interval with a confidence level of 98%. That means the confidence level is 0.98. And the question is, construct the confidence interval for the variance, or I will simply say estimate the variance. Okay, so I will start by writing down the formula, sigma squared. Because it's the variance, I will simply write down the upper and the lower bound without putting the square root, since this is already squared. So I have n minus 1 times s squared divided by chi squared to the right, and n minus 1 times s squared divided by chi squared to the left. I am looking at the information. Do I know n? Well, n is 15 and will be then placed in here. Do I know s? I don't. Do I know sigma? Do I know the critical values? Well, I'll have to find it using the table. So let's see, how do we find s? Well, since we have raw data, all we have to do is place the data on the calculator under edit, enter data in list 1, and then find the one variable step. We've done this before, and look at the screen for SX. That will be our standard deviation. So let's do that. So here I have my stats screen, edit. I have already entered these values in one list, and I go back to stats. I use calc. And one variable stats is all I need. Do I have my values in list 1? Yes. And I will simply calculate. And all I need from this screen is SX. This is the sample standard deviation, which is 2.51 if I round this to 2 decimal places. So I'll write this down. S is 2.51. I will invite you to use the table to find chi-square to the right and chi-square to the left. And if you've done that correctly, chi-square to the right is 29.141 and chi-square to the left is 4.660. Now I have all the components and I'll simply plug in 15 minus 1 times 2.51 raised to the second power all over 29.441 2.141 and 15 minus 1 times 2.51 squared divided by 4.660. Using your calculator, you can find these values. Do so and check. Here are the answers: 3.026 and 18.927. Since I must find the confidence interval for the population variance, I use the proper symbol right here, and I do not square root these upper and lower bounds. So make sure you know when you square root this and what symbols goes along with that process. Let's do one more problem. Problem 3. The average waiting time in the doctor's office varies. A random sample of 30 patients in the doctor's office has a standard deviation of waiting times of S equals 4.1 minutes. Calculate the 95% confidence interval for the population standard deviation sigma for waiting time. Given information, now this is about average waiting time, and we have a random sample of 30 patients. S is 4.1 minutes. The confidence level is 0.95. And the question is estimate standard deviation sigma. So I will start by writing down the formula and then see what I need to complete this problem. This is sigma, is not variance, not sigma squared. So I need to square root the lower and the upper value. And the formula goes by this: n minus 1 times s squared divided by chi squared to the right, n minus 1 times s squared divided by chi squared to the left. I have n, I have s, I have the confidence level. So all you need is find the chi squared to the right and chi squared to the left. And that's why this was the first exercise in the video, and we did practice on 2 problems. So make sure you know how to find these values. And if you've done this correctly, here is what I have: 45.722 for chi squared to the right and 16.047 for chi squared to the left. All we need to do is just plug the numbers in, use the calculators to do the calculations, and we will come up with a confidence interval for standard deviation sigma. So if you've done this correctly, your answer should be 3.66 on the left and 5.51, actually 5.512 on the right. So the standard deviation is between 3.266 and 5.512 minutes. With this, I conclude the video.